When evaluating working space around electrical equipment like a 480 volts motor control center, or MCC, adherence to the National Electrical Code, specifically Section 110.26 is paramount. This section focuses on ensuring sufficient space for personnel to safely operate and maintain the equipment. The key question revolves around where to measure the required working space when you have exposed live parts on one side of the MCC, such as the bus, and grounded parts, like mechanical piping, on the other. Section 110.26 dictates the working space requirements for equipment operating at 600 volts, nominal, or less to ground. It emphasizes that sufficient access and working space must be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. Now, let's delve into the specifics of where to measure this working space in your scenario. The code specifies that where the conditions are such that contact with parts of the circuit operating at over 250 volts to ground is likely, such parts shall be guarded or isolated. The term guarded is crucial here. Guarded means that the exposed live parts are arranged, covered, shielded, enclosed, or otherwise protected by suitable covers, casings, barriers, rails, screens, mats, or platforms to remove the likelihood of approach or contact by persons or objects to a point of danger. In the context of your MCC, with exposed live parts on one side and grounded parts on the other, the measurement for working space as per 110.26 is taken from the face of the MCC, specifically the bucket door, to the grounded surface. This is because the code is concerned with the safety of an observer standing on the floor or working normally on or adjacent to the equipment. This individual could potentially come into contact with the exposed live parts if adequate guarding and clearance are not provided. The working space dimensions specified in 110.26 vary depending on the voltage to ground and the condition. There are three conditions outlined in the NEC that affect the required working space depth. These conditions are critical in determining the necessary clearance. Condition 1 states that the exposed live parts on one side and no grounded parts or grounded parts suitably guarded are on the other side of the working space. A minimum depth of 3 feet is required for 150 volts to ground or less, 3 feet for 151 to 600 volts to ground, and 3 feet 6 inches if the voltage is 601 to 2500 volts to ground. Note that these conditions are based on voltage to ground, not phase-to-phase voltage. Condition 2 involves exposed live parts on one side and grounded parts on the other side. When this is the case, the depth increases to 3 feet for 0 to 150 volts to ground, 3 feet 6 inches for 151 to 600 volts to ground, and 4 feet for 601 to 2500 volts to ground. Condition 3 applies to exposed live parts on both sides of the working space. Here, the minimum clearances are 4 feet for 0 to 150 volts to ground, 4 feet for 151 to 600 volts to ground, and 5 feet for 601 to 2500 volts to ground. To illustrate, if your 480 volts MCC is exposed live parts and a grounded surface within the working space, condition 2 applies. Therefore, the minimum working space depth required would be 3 feet 6 inches. It is vital to understand that these are minimum requirements. Providing additional space is always recommended to enhance safety and accessibility. The measurement is taken from the front of the equipment, in this case, the MCC bucket door, because that is the point from which a person might be working. The grounded surface represents a potential contact point, so the distance between the two must meet the code requirements. This ensures that there is adequate space for a person to avoid accidental contact with live parts. Now let's discuss some additional considerations. Firstly, the working space must be clear and unobstructed. This means that you cannot have any equipment, storage, or other items within the designated working space. This ensures that personnel can move freely and safely while working on the equipment. Secondly, the working space must be properly illuminated. Adequate lighting is essential for safe operation and maintenance of electrical equipment. The NEC requires sufficient illumination to allow personnel to clearly see what they are doing. Thirdly, consider the height of the working space. Section 110.26 A3 requires a minimum headroom clearance of 6 feet 6 inches or the height of the equipment, whichever is greater. This ensures that personnel have enough headroom to work comfortably and safely. The NEC also addresses situations where equipment is installed in dedicated electrical rooms or enclosures. In these cases, the working space requirements still apply, but there may be additional considerations such as ventilation and access control. Proper ventilation is crucial to prevent overheating of the equipment and to maintain a safe working environment. Access control is also important to prevent unauthorized personnel from entering the electrical room or enclosure. Another important aspect to consider is the maintenance of the working space. It is not sufficient to simply provide the required working space at the time of installation. The working space must be maintained throughout the life of the equipment. This means regularly inspecting the working space to ensure that it is clear, unobstructed, and properly illuminated. Any obstructions or hazards should be removed immediately. Now let's discuss some common misconceptions about working space requirements. One common misconception is that the working space requirements only apply to new installations. In reality, the working space requirements apply to all electrical installations, regardless of age. This means that even if an existing installation was compliant with the code at the time it was installed, it must still be brought into compliance with the current code if any modifications or alterations are made. Another common misconception is that the working space requirements are only for the protection of qualified electrical workers. While it is true that qualified electrical workers are the primary beneficiaries of the working space requirements, the requirements also provide protection for other personnel who may be working in the area. This includes maintenance personnel, cleaning staff, and other individuals who may be present in the vicinity of the electrical equipment. Another important consideration is the type of equipment being installed. Different types of equipment may have different working space requirements. For example, switchboards and panel boards may have different requirements than motor control centers or transformers. It is important to consult the NEC and the manufacturer's instructions to determine the specific working space requirements for the equipment being installed. In addition to the NEC requirements, there may also be local codes or regulations that apply to working space. It is important to check with the local authorities to determine if there are any additional requirements that must be met. These local requirements may be more stringent than the NEC requirements, so it is important to be aware of them. Let's consider a few practical examples to illustrate how the working space requirements apply in different situations. Firstly, imagine a scenario where an MCC is installed in a narrow hallway. In this case, it may be difficult to provide the required working space depth. One option would be to relocate the MCC to a different location where there is more space. Another option would be to use a smaller MCC that requires less working space. Secondly, consider a situation where an MCC is installed in a room with a low ceiling. In this case, it may be difficult to provide the required headroom clearance. One option would be to raise the ceiling. Another option would be to use a shorter MCC that requires less headroom clearance. Thirdly, imagine a scenario where an MCC is installed in a room with a lot of equipment and storage. In this case, it may be difficult to keep the working space clear and unobstructed. One option would be to remove the equipment and storage from the working space. Another option would be to use barriers or other means to protect the working space from obstruction. Compliance with NEC 110.26 is not just about adhering to regulations. It is about ensuring the safety of personnel who work with and around electrical equipment. By providing adequate working space, you reduce the risk of electrical shock, arc flash, and other hazards. Remember, electrical safety is everyone's responsibility. By understanding and following the working space requirements, you can help to create a safer working environment for yourself and others. Now let's touch upon the role of the electrical inspector. The electrical inspector is responsible for verifying that electrical installations comply with the NEC and other applicable codes and regulations. This includes verifying that the required working space is provided and maintained. The inspector may use various methods to verify compliance, such as visual inspection, measurement, and testing. If the inspector finds that the working space is not compliant, they may issue a violation notice and require the issue to be corrected. It is important to cooperate with the electrical inspector and to address any violations promptly. Failure to comply with the electrical code can result in fines, penalties, and even legal action. In conclusion, understanding and applying the working space requirements of NEC 110.26 is crucial for electrical safety and code compliance. Remember to measure from the face of the MCC, specifically the bucket door, to the nearest grounded surface, and ensure that the working space is clear, unobstructed, and properly illuminated. By following these guidelines, you can help to create a safer working environment for yourself and others. Remember to always consult the latest edition of the NEC and to seek guidance from qualified electrical professionals when needed. Electrical work can be dangerous, so it is important to take all necessary precautions to protect yourself and others. This detailed explanation should provide a comprehensive understanding of the working space requirements for MCC and other electrical equipment. Always prioritize safety and compliance when working with electricity.